Hello. My name is Elias, Starr, and I am a 7th grader who attends Talcott Mountain Academy. My project for this year's Invention convention is called the Secure Stove. The Secure Stove helps mitigate the problem of houses burning down due to unattended stovetops. Despite the commonality of this issue, there are few affordable products that help mitigate this problem. The Secure Stove is both affordable and efficient at stopping these house fires before they even start. Here's a graph that shows the increase in deaths caused by house fires. Here is a chart showing the percentage of which stoves are involved in house fires. The Secure Stove does this by using 4 main components, which are a 12-volt solenoid, a piezo buzzer, an LCD display screen, and 4 buttons. The Secure Stove works by setting a timer on the LCD display with the buttons, and when the timer's up, the 12-volt solenoid shuts and the piezo buzzer alarms. The box holds everything in place, and in the future will be used as an insertable plug-and-play box. These 4 simple components will allow the Secure Stove to be cheap and effective compared to its competitors. Currently, I have wired the Bluetooth components into the Secure Stove. However, I am yet to code an app that will allow the Bluetooth module to control the phone. Costing $28.50, the Secure Stove is significantly cheaper than the competing products that range from $80 to $1,000. The invention process went through 5 main stages, which are the first prototype, the 5-volt solenoid, the 12-volt solenoid, and the second prototype, and the current prototype. The initial design of the Secure Stove consisted of a servo motor, 4 buttons, an LCD display, and a piezo buzzer. In order to reach this stage, it took me 1 month of research on how to code and wire the components, and 1 month to actually build the prototype itself. This stage was the first major landmark on the journey towards the final product. When testing this prototype, the servo motor used could not close or even move the mechanical gas valve used for testing, and as a result, I decided to swap to a solenoid valve. This is when the second design stage began, which was the 5-volt solenoid testing stage. After testing this servo motor, I envisioned that I would eventually use a 12-volt solenoid. However, I first used a 5-volt solenoid to test the wiring and get the basics down. This stage was very short, as it was just coding and wiring the solenoid on a separate breadboard. The 12-volt solenoid stage was very similar to the 5 volts, however, it simply just required a 12-volt solenoid. This just made it riskier to put into the Secure Stove, and as a result, it took me 2 weeks due to multiple errors encountered along the way of this design stage. The second prototype required me to implement the 12-volt solenoid into the Secure Stove itself. Due to the fact that the components I had on the Secure Stove all operated on 5 volts and the solenoid valve uses 12, I almost burnt out my entire circuit, including the Arduino itself. This stage mainly consisted of testing, as once I had implemented the 12-volt system, all that was left to do was test. Here is an image of the first prototype, and here is an image of the second prototype. The current prototype is now on the Arduino Mega to allow the wiring of the Bluetooth components and is in a custom 3D printed box. In the future, the Bluetooth will alarm a person's phone when they leave the house if their stovetop fire is on. The box allows everything to be in compact frame, and this prototype is the next step towards the end goal of my product, which is to have a compact prototype all set and ready in a play box. In order to show you my working prototype, I am going to set a 1-minute timer, and by the end of this presentation, it will have gone off. Here's the decrease time, the start button, the set button, and the add time. In order to be able to add the Bluetooth feature into the Secure Stove, I was required to transfer all of the wiring over to the Arduino Mega board. This board has 3 times as many pins as the Arduino Uno, allowing me enough pins to fit the Bluetooth module. I've also added a prototype plug-and-play blocks, which has allowed a more accurate prototype to the final version. With the secure stove nearing its final design stage, I only need to add and adjust a few more components before the secure stove is completed. These components are mainly the Bluetooth and the box. Currently, the connection between the Arduino and phone is a kind of, the phone controls the Arduino rather than what I want, which is the Arduino controlling the phone. Here I'm going to show you the timer. As you can see, the buzzer buzzes and the solenoid valve just clicked up shut. Thank you for watching how my invention works.